This is just not possible to multiply the matrices together.
What if you have the outside numbers the same as the middle numbers?
Good question. What if the outside numbers are the same but the middle numbers are different? You can't multiply them together. You could multiply them in the reverse order. Like, for example, if A was 3 by, we could change this problem. If A was, say, 3 by 4 and B is a,
2 by 3.
sure, is a 2 by 3, you would not be able to multiply A times B. But you could multiply B times A. If you did B times A, you'd have a 2 by 3 and a 3 by 4. If you did B times A, then you could find B times A, which would be a 2 by 4 matrix when you're done. But you would not be able to multiply them in this order.
Are you allowed to switch them anytime you want?
Good question. 1 plus 15, 16, negative 4 plus negative 10, is negative 14. Would be the product of these two matrices. Again, we'll find each of these positions by taking, if we want row 1, column 1, we'll multiply and add row 1 to column 1. Row 2 to column 2. Sorry, row 1 to column 2. Row 2 and column 1. Row 2 and column 2. Be what we're multiplying together. Then we'll add the two numbers that the result. Okay. Again, think about it as taking this column and multiplying it to each one, the first, going down and going across. And we'll get ourselves a new matrix. Then simplify. Okay. Let's try it again. Let's try it again. We want our resultant matrix here. Our resultant matrix should be, if I want the row 1, column 1 element, I'll take row 1 and multiply it to column 1 of the second. So if I want the first element, the first row, first column, first row times first column, or negative 3 times 1 is negative 3, plus 3 times negative 3 is negative 9. Will give me the first element of my product. If I want the element that's in row 1, column 2, I'll multiply row 1 in the first by column 2 of the second. So negative 3 times 5 is negative 15, plus 3 times negative 2, which is what, negative 6. If I want row 2, column 1, I'll multiply row 2 by column 1. And get 1 times 1 is 1, plus negative 2 times negative 3 is 6. Row 2, column 2, row 2 times column 2. 1 times 5 is 5, plus negative 2 times negative 2 is 4. Which gives a resultant matrix of negative 12, negative 21, 7, and 9. In the case of these examples on the backside, orders of operations would tell us that we should subtract B and C first, and then we'll multiply by A. So in our first example, let's create a matrix where we subtract B and C first, and then multiply by A. So what's the matrix B minus C? What should that look like? A is this. And then B minus C. We'll subtract them element by element. It'll be what? 2 minus 2 is 0. Negative 3.
Negative 4.
Well, yep, negative 3 minus 1 is negative 4. 1 minus negative 4 is 5. 0 minus -2 is +2. Okay. Can we multiply these matrices together?
Yes.
This is a 3 by 2, and this is a 2 by 2.
Yes.
Yes.
Yeah, we should be able to. The columns match the columns match the rows. So we should get a resultant matrix, and let's see what that resultant matrix looks like. This should be equal to row 1, column 1. Row 1 times column 1. So 3 times 0 plus -2 times 5 would be row 1, column 1. Row 1, column 2 would be 3 times -4 plus -2 times 2, -4. Row 1, column 2 would be row 1, column 2. And we'll continue. So row 2, column 1 is 0 plus 20. Row 2, column 2 would be 0 plus 8. Row 3, column 1 would be 0 plus 5 times 5, or 25. And row 3, column 2 would be -1 times -4 plus 5 times -2. Or simplify all this stuff, and you end up with what? 0 plus -10 is -10. 20. 25. -16. 8. And 14. This should match.
Oh, that was the problem.
It should match your previous answer here if you did it correctly. Multiply the inventory matrix with this cost matrix. What, 15, 20, 18, and 30. What's the dimension of this matrix? 3 by 4. This is a 4 by 1, right? So then what should our total value matrix be? What's the dimension of our resultant matrix, our total value? 3 by 1. Or probably our 3 by 1 matrix will tell us the value at each of the 3 stores. That's how much money each of these 3 stores has. So if we multiply this 3 by 4 by this 4 by 1, you'll end up with a 3 by 1 matrix that tells you the value at store 1, at store 2, and at store 3. Pretty neat. So, in that respect, how neat is that? So you can multiply these two matrices together. And notice you get a 3 by 1. You'll get row 1, column 1. Row 2, column 2. Column 1. Row 3, column 1. And get an answer. Now, I would do this with a calculator. There's no way I do this in my head. Use a calculator. Multiply these numbers and just add them together to get your resultant matrix. And your resultant matrix will be a 3 by 1, where it tells you the value at store A, the value of store B, and the value of your merchandise at store C. Okay.
Add those 4 up and then times it by
So I could multiply row 1 by column 1, and that'll tell us what value A is.
So much cash.
Work your way left to right. and top to bottom. So 2800 by 15, 550 by 20, 200 by 18, 150 by 30. Add them together.
And then you get
The first element in our 3 by 1 matrix. Then we'll take row 2, column 1, to get row 2, column 1 of our resultant matrix. So we'll take 2600 by 15, 800 by the second element, the third by the third, the fourth by the fourth. Add them together, and you get element B, row 2, column 1. Then if you want row 3, column 1, row 3, column 1. Add element, multiply element by element, add together, and you end up with the third element. And each of these will be the price or the value by store.